Okay, what I'm going to do here is test this Google Nexus 7 pad with the Blackbox Toolkit robotic finger. And the Blackbox Toolkit sends to check Android app, which is basically going to display a white block, and it's got a button that accepts input. What we're going to do is use DASCA on the Blackbox Toolkit to wait 300 milliseconds after seeing a white stimulus image. Then we're going to fire a response in using the finger, and we're going to hold that down for 100 milliseconds. So I'll just start the app off first. Right, so we see the white block, and now we can see the finger positioned over the button that needs to be clicked. So I'm going to start DASCA off. So basically I'll just do the first one. So as we can see, it should be responding after 300 milliseconds. Right, so if we look at the reaction times of what the pad thinks, they vary between about 417, 452, 436, 453, 441, 582, 437, 457, 445, 515, 443, 400, 575, 539, 434. Right, so it's basically the same test again, but this time it's our ice cream sandwich 7-inch pad. So it's only a single core, this one, but it's basically Android again, so we'll just zoom in a tad. Now set it going by touching it first time round, and I'll set the Blackbox Toolkit going. So I think now we can notice that there's a big difference already. So it's very slow displaying the bitmap. There should only be 1000 milliseconds ISI on that. So the reaction time it's recording is 821 on that last go. That's 87 milliseconds. Obviously there's a fair few seconds ticking past before the image is displayed again. Again, identical Android app, just a different tablet. Identical setup on the Blackbox Toolkit, just a different pad. So again, 84 milliseconds for that one. 85 milliseconds for that. Again, we should be getting reaction times of 300 milliseconds with a 1 second or 1000 millisecond ISI. And again, we're not getting that. Okay, so what I'll do is I'll show you what that looks like on the actual Blackbox Toolkit. So what I'm going to do is clear the memory, ready to download the program to the box. I'm going to load the program up that we're using for a test. I'm going to program the box with that program, so it's 60 seconds and 20 events, that's 20 responses it's going to do. And then I'm going to start that. So what I've just done is set the pad going. So there you just had a response, so that's responding to a visual stimulus. There's another one. And there's another one. As you probably notice we've got the mic on there, so what we're trying to do is capture the audio from the click on the robotic finger. Okay, what I'm going to show you now is the Blackbox Toolkit software actually testing one of those Android pads. So basically the first thing I need to do is bring up DASCA. And that's basically how you program digital stimulus capture and response. So basically look for a stimulus, which in this case is going to be a bitmap, and then fire a response in, which in this case is going to be the robotic finger going down and triggering the pad. So basically I'll use the auto sequence generator. I'll say, okay, see an event on Opto 1, wait 300 milliseconds, and then I'm going to look at what response to generate. So I've got the robotic finger on TTL out 1, so what I'm going to do is hold that down for 100 milliseconds, and I'm going to do 20 events. So it's Opto 1 and TTL out one which will trigger the robotic finger. So I'm going to generate that. So that's basically built as a schedule. I could have loaded that in, but at least now you've seen how you do it. And I'm going to run it in this case just for, I don't know, 30 seconds rather than running it for too long. Next thing to do is clear the memory on the BlightBots toolkit. So that's just formatting now. It's actually ready. I'm going to program the toolkit. So this downloads a sequence into the ARM chip and gets it ready to go. So what I'm going to do now is start that, and I'm just going to wheel over to the pad and click on the start button on there as well. So click start there, click start on the pad. So it should start to respond now. So hopefully you can hear that responding. So it's pretty much as early in the video, apart from this is a BlightBots toolkit side of the software where it's actually doing the thing. Again, the box is totally autonomous once it's programmed, so it's doing its own time stamping, deciding what to do and all the rest of it. Right, so that's uploaded the data from the box, and we get some rough capture stats. So it'll tell you how many responses were fed in. So that's basically TTL signals, basically. The runtime and how many samples were taken. So we just click on done. That basically parses all the raw data from the ARM chip, does a line-by-line analysis for line changes, and then we have a summary sheet there. So here we can see the optos, basically looking at the durations. So the durations for the bitmaps are pretty consistent, and we know that we fired a response in at 300. So basically instantly we know that the reaction times are completely wrong on this Android pad, because basically the bitmap should terminate at 300. So obviously it's a lot added on there. It's basically 250 milliseconds on top with a bit of wobble. We can see the mic as well. We're not too interested in that at the moment, but we can see the TTLs as well. So that's a robotic finger, so we can see that that's just about held down for 100 milliseconds. So that's pretty close. One of the things that we're interested in is the actual plot down there. Again, we've got some capture stats down there, so it just basically tells you what thresholds the sensors were on. So you can see the optos on 120 out of 127. It gives you some capture stats as well. So basically here's the opto, so you can see there's when an image appears, and then we can see our response that we fired out on the finger here. And basically what we can do is bring up some measurement cursors by pressing M. Then what we can do is roughly snap to the front of the first stimulus and snap roughly to the front of our response. Again, you could do this in the spreadsheet as well. Then what we can do is zoom in, so we'll zoom around those 2 points, zoom in again, and what we'll do, we'll just snap that to the front of there, zoom out, again zoom in, and basically what we can see is we've got 300 milliseconds for our robotic finger, so we know that we did actually fire a response out of 300 milliseconds. So basically we'll zoom back out, and basically we can see that the actual bitmap, which should have terminated in line with that, basically terminated a long time afterwards. So what we can do, because it should have terminated at 300, we can drop down and measure the offset. So again, I'll just zoom in again. Let's make that a little bit bigger. Just zoom back out so I can see that. Right, there we are. So I've snapped it onto the end, so you can see that 551 is the actual difference between those two measures. So basically we know that from the spreadsheet already that those bitmaps were on for way too long. So basically this just confirms that. The other neat thing you can do is we'll go right back out so you can see the whole plot. What we'll do as well, we'll press H for highlight, and what that'll do is it'll automatically highlight the onset for the line that we're looking at. So here we can see it's found it in the spreadsheet there. And basically what we could have done is we could have gone up there to the front of there, pressed highlight again. You can see that it'll point you in the direction of the onset of the TTL out as well. So that's quite neat, so you can snap around the spreadsheet. So again, you've got quite a big sheet that you can put in Excel if you need to as well. Key thing though is probably the data analyzer down here, and again you can see the audio, but obviously I talked over it, so it's not very good basically.